Hello viewers and welcome to my YouTube channel. This is question number 16 from IIT JAM question paper of 2015. It's a 2-mark problem from section A. We are given a matrix A with entries in complex, and we have another matrix B which is expressed as the product of A transpose times the conjugate of A. And then we are expected to interpret about the eigenvalues of A and B. So for the first part, we are going to discuss about the eigenvalues of A, and that we will be doing in a very traditional manner. So we will start with the evaluation of the characteristic equation that's given by determinant of A minus lambda I equals 0, and this is going to be the determinant of negative lambda 1 minus I, negative 1 negative I, and I minus lambda is equal to 0. So this becomes negative lambda times I minus lambda minus 1 minus I times negative 1 minus I is equal to 0. Simplifying, we are going to get the first part to reduce to negative lambda I plus lambda square, and over here if we take the product of these two linear terms, so we are going to get negative 1 minus I and then plus I, and negative I times negative I is going to be negative 1 is equal to 0. So this is lambda square, a little bit of rearrangement, minus lambda I, and over here we can get rid of this. So the bracket is only negative 2 and we already have a negative outside, so this is plus 2 is equal to 0, which is quadratic, and we can use the formula method to solve and get the roots. So the roots are going to be minus b in this case is negative I, plus minus square root of b square, that's again negative I square, minus 4 into a, which is 1, into c, which is 2, over 2a. So that's 2 times 1. So we get lambda is equal to I plus minus, this factor is going to be negative 1 minus 8 over 2, and you can see that inside the root we have negative 9, so that is going to become 3i over 2. So we get the two eigenvalues to be I plus 3i over 2, that's 4i over 2 reducing to 2i, and I minus 3i over 2. So again this is going to be negative 2i over 2, that is negative I. Thus both the eigenvalues for A are complex. Now if we look at option B, an eigenvalue of A is 0, so this is an incorrect option. And if we look for option D, A has a non-zero but real eigenvalue, so this is also eventually incorrect. Now we got to talk about the eigenvalues of B. So for that we are going to first evaluate B, and it goes like this. It is given to us that B is equal to A transpose times the conjugate of A. Now the conjugate of a matrix A means that every entry we are going to take the complex conjugate. So starting with the 1 1 entry, which is 0, the conjugate of that is 0. Now this is 1 minus I, we know that its complex conjugate is 1 plus I. Negative 1 minus I, so that would be negative 1 plus I, and lastly we have an I here, so this is going to be negative I. Now we will take the product, so we will have 0 times 0 plus minus 1 minus I times minus 1 plus I, and the first row second entry is going to be again 0 plus minus 1 I times negative I. Second row first entry is going to be 1 minus I times 0 followed by plus I times of minus 1 plus I, and the second row second column entry is going to be 1 minus I, 1 plus I, plus I into minus I. So simplifying the first entry, now you can see that it is of the form A plus B and A minus B. So it is going to be A square minus B square. So that is going to be negative 1 square minus I square. For the second one, we will have I plus I square. Then this term is 0, and then the next one is going to be negative I plus I square, and then the last entry is going to be, so over here this factor again is a plus b, a minus b, so we can write it as a square minus b square, and then followed by another minus I square. Simplifying these terms, we get the first entry to be 1 minus minus 1, the second entry to be I plus minus 1, we have minus 1 plus minus 1, and lastly we have 1 minus minus 1 minus minus 1, which reduces to give us the matrix P as 2, negative 1 plus I, then negative 1, negative I, and lastly we have a 3 here. So we have got a matrix now B, and we wish to evaluate the eigenvalues for B, and that will be given by the characteristic equation, which is determinant of B minus lambda I equal to 0, and that is going to be 2 minus lambda, negative 1 plus I, negative 1, negative I, and 3 minus lambda, determinant is 0. So this is 2 minus lambda times 3 minus lambda minus minus 1 plus I and minus 1 minus I equals to 0. So from here we will get a quadratic equation that will be 6 minus 5 lambda plus lambda square. Again, these two factors are of the form a plus b into a minus b. So this is going to give us a square, which is minus 1 square minus b square is equal to 0. So we have 6 minus 5 lambda plus lambda square, and from this expression we will get 1 minus negative 1 equal to 0. So that's 6 minus 5 lambda plus lambda square, and this term right over here becomes 1 plus 1, 2, so we have a minus 2 equal to 0, and therefore the characteristic equation reduces to lambda square minus 5 lambda plus 4 equal to 0, which can be easily factored into lambda minus 4 and lambda minus 1 equals to 0. Thus the eigenvalues for B is 4 and 1. So we have got two real eigenvalues for B. Now if we quickly have a check on option A, an eigenvalue of B is purely imaginary, so this is absolutely incorrect, and by ruling out all the unfavorable options we can make out that C is correct. Also, if we read it, that all eigenvalues of B are real, which indeed is happening in this case, so we can carefreely take out option C as the correct option. So that's all for now. I hope you follow through this long video, and I have tried to still keep it as short as possible. Thank you so much for watching till here, and do subscribe to my channel so that you do not miss the upcoming videos. I will be trying to pull up new topics from mathematics that are helpful for IIT JAM, CSIR, NET as well as SET examinations. Thank you once again and happy learning.